This is the second half of the problem-solving slides, which is basically density and specific heat. So if you remember, we went through density problems, did this whole mess here. Okay, so now we're going to look at another relation. I mentioned before there's a relationship between heat and temperature. This is really more about the problem solving than this relationship. That relationship is this on the left. So Q is something we use for heat. T is temperature, and that's ms. This is a Greek letter delta, which means change in, right? So Q, this is actually a heat change, is the mass times what's called the specific heat times the change in temperature. So Q is the heat. Usually we use the unit joules, okay? The old unit of heat, interestingly, was called a calorie. It's abbreviated as CAL. And a calorie is an arbitrary unit. It's the amount of energy required to raise the temperature of 1 gram of water 1 Celsius degree. So it's specific for water. When you read calories on food, all right, so basically what happens with food, why do we count calories if we're looking at fat or weight gain? What happens is food has energy stored in chemical bonds. Any energy that you don't use, your body says, oh, let's save it for later, and it makes molecules called fat. That's how it's stored. So if your caloric intake is greater than your caloric burn, you're going to save it for later, so to speak. A nutritionist calorie is actually a kilocalorie, and it's abbreviated with a capital C. That's just some Judas. M is the mass. Okay, S is the specific heat. This, again, is a physical property. It's the amount of energy required to raise the temperature of 1 gram of whatever that substance is, 1 Celsius degree, so it's joules per gram degree C. And again, specific heat tells how well things absorb heat. So things with high specific heats takes a lot of energy to get them hot, and they hold heat well. They're good insulators. So water, for example, takes a lot of energy to get it hot. One of the most expensive things you do in your home is heating water. So if you're trying to cut down on power that you use to heat water, like typically gas, take shorter showers or something like that. All right. Things that heat up very quick have low specific heats, like metals. They get hot really fast. They also cool down really fast. Right? And then last thing, delta T is the temperature change, so it's defined as the final minus the initial. Textbooks will typically use 1s and 2s. I like descriptive subscripts. You can use whatever you want, but make sure you know which is which. So you can actually rewrite this as Q is ms Tf minus Ti. How do you know if you should use delta T or Tf minus Ti? It depends on the question. If you're given initial and final temperatures, you would use this. If you're told the temperature changes by, you can use that. One last interesting gee-whizzy thing, this can actually be negative if something cools off. Okay, in science we use sign to indicate direction. So if we define up as positive, then down is negative, and so on. In this case, if Q is less than 0, that means it lost heat, heat left the system. If Q is greater than 0, it gained heat. Okay, so there's some gee-whiz and there's the equation. So now I'm going to do 3 problems. All right, so there'll be different levels of difficulty. Watch the problem solving and the sig figs. These are very algebraic. So let's start with how much heat to raise the temperature of this much water from 4 to 95 degrees. You do not need to memorize any numbers like densities or specific heats. They will be given to you. All right, so let's go through the problem solving. Make lists of the variables. So let's go back. So the variables, right, we're doing this algebraically. We have Q, we don't know. That's what we're being asked. We have the mass, and again, it doesn't say has a mass of, so how do we know the mass? This is where you can use units to help you. That's the mass. All right, specific heat was given. Now, we have 2 temperatures, so the from is the initial, the to is the final. So the final temperature is 95, the initial temperature is 4. So now we can go to the equation. Q is ms delta T, but since we have 2 temperatures, Q is ms Tf minus Ti. So now we're going to plug the numbers in. And I'm sure your math teachers told you, take that extra minute to write down this, because it's really easy to accidentally put Tf where Ti should be. But if you write them down, it's harder to make mistakes like that. All right? So now we're going to plug in the numbers. M went here. There's your S, Tf, Ti. Doing the math, because we have a subtraction, 91.0, watch, this becomes 3 sig figs. Remember, the zeros are significant here. And then because we're multiplying and dividing now, 4, 4, 3, the answer will have 3 sig figs. Notice the units cancel. Oh, it shouldn't have the S in there. Oh well. Notice that the units will cancel, grams cancel, degrees cancel. We should get joules. And there's your answer. Right. I'll go back and fix the slides, but I'm not going to redo the video. I'll get rid of that S. All right. Next problem. This one's a little bit more challenging. So again, you can try these on your own and then walk through this and hit pause, or you can just watch me go through it. And like I said, this will be the 4th time I've said it or whatever. I'm going to do a Zoom session during our synchronous meeting. You'll see it and you see it in your schedule. But I'll have a worksheet that you guys can go over, and I'll go over them in class. All right, so again, let's make a list of the variables. Q this time is this. Again, how do we know? Well, it says of energy and joules will be Q. Mass, 300 grams. There's your specific heat. TF is what we're being asked. TI is what we're told. All right, so let's go over here, and I'm going to keep track because we have addition and subtraction here. We have to watch this. So we want to solve for TF, so this will be a good review. I'm going to divide both sides by MS. So Q over MS is going to be TF minus TI. And I'm going to add TI to each side. So that means TF is going to be Q over MS plus TI. Now I'm going to put the numbers in. All right, so Q, 26,985, M, 300.0, and there's your S. The units here, joules cancel, grams cancel, this would be degrees C, and then TI was 9 degrees. Now look, I have 5 sig figs, 4 sig figs, 4 sig figs, 2 sig figs. So now I'm going to do this math. That comes out to be 4 sig figs, 18.69 degrees C. So that's the last sig fig. That 0 is the last sig fig. So remember, when we add and subtract, it's the decimal place. So we're good to the 10ths place, not the hundredths. So we end out with 3 significant figures. It's always reasonable to say, does my answer make sense? Right? Water really absorbs heat well. All right? Give yourself a minute to look at this, and again, feel free to hit pause. All right, this last problem is a tough one. So I'm going to walk you through this. So this one says, what's the final temperature if 150 grams of iron, and that's the specific heat of iron, right here, at 220 degrees C is put into 2820 grams of water, specific heat of water, at 8 degrees C. All right. Now, what's different about this problem is we have 2 things in contact. We have 2 initial temperatures, right? It looks like we have 2 heats. So this is where the law of conservation of energy comes into play. Remember, total amount of energy is unchanged. Another way of saying it is that the sum of the heat changes is equal to 0. Remember, Q is actually the temperature change. You can't have a negative heat, but you can have a negative change of heat. So another way of writing this out mathematically is say that the sum of the Q's, sum of the temperature changes is 0. QFE plus QW equals 0. All right, so now let's go ahead and make a list of our variables. Okay, so we don't have the Q's, but we do have the masses. We have the mass of the iron, and there's a lot of numbers here, so make sure you keep track. That's why I don't just write mass, I write mass of what? I like descriptive subscripts. Mass of the water. You can do whatever you want, but a lot of stuff I do is from mistakes I made. It's really easy to switch numbers, so if you label things clearly, it's much harder to make mistakes. Specific heats are given, and then we have the initial temperature of the iron, and the initial temperature of the water, and we have, it says the final temperature, and it's implied here the way the question's written, what is the final temperature, that there's one, but also from experience, if you put hot stuff in cold stuff, everything eventually comes to the same temperature. So in this case, the final temperature of the iron is equal to the final temperature of the water, so we're just going to call it the final temperature. All right, so the next slide has the problem solving. And so these numbers that are here, I can't plug everything in down here, but I checked it 5 times. All right, here we go. Here's the problem solving. Ready? Strap yourself in, put your seat backs and tray tables in their upright and locked positions. Make sure your seat belts are fastened, and yeah, here we go. All right, so watch the sig figs because there's addition, subtraction, and multiplication division. I'm going to put the last sig fig in red, keeping 1 extra digit. So we'll start with there. But we don't have any of the variables we want in there, so I'm going to expand it out. Q is MSTF minus TI. MSTF minus TI. It looks complicated, but I'm just writing for the iron, so I put the mass of the iron in the right place. Now, you kind of have to go back to the previous slide to see the numbers, or you can kind of get them up here. This is the mass of the iron, specific heat of the iron, TI of the iron, mass of the water, specific heat of the water, TI of the water. And so you'll see in the next, there, I put them all in. All right, from the previous slide, I listed them out. Okay, at this point, let's say I gave you this as a 10-point problem on an exam. This is 8 of it. But you want to get 10, you want to get all of it, because you want to get the right answer to the correct number of sig figs. One other thing before we go further, think about what can you tell me about that final temperature? You know, does my answer make sense? All right, I stopped so you could hit pause. The final temperature is going to have to be between 220 and 8. Right? If I put a hot piece of metal in cold water, it's not going to be hotter than the metal was, and it's not going to be colder than the water was. So it's going to have to be between those two. You can't look at this and go, oh, there's only 2 sig figs, right? Because it's got addition and subtraction. So now what I'm going to do, I'm going to multiply these two together, the 150 and the 0.473, and multiply the 2820 and the 4.184. Notice that the grams will cancel. So you see 70.9, right? And 11,800. This number has 3 sig figs. This number is going to have, this has 3 sig figs, and this has 4, so this has 3 sig figs. Now I'm going to distribute through here, so that the degree C will cancel. So 70.9 times TF, 70.9 times 220 is this. And again, that has 4 sig figs, but this only has 3. Distributing this through, 11,800 times TF, and 11,800 times 8. The 8.0 has 2 sig figs. Now I'm going to combine the joule per degree C terms, the TF terms, and I'm going to combine the joule terms. So when I add these two together, I'm precise to the hundreds place. When I add these two together, I'm precise to the thousands place. All right, so again, see, this goes to the hundreds place. I kept the extra digits. This is good to the thousands place. Now we're almost ready to solve this. All right, so just moving this over. Now we want to divide each side by 11,871. And we should notice joules will cancel. We'll get degrees C. And this has 3 sig figs. This has 3 sig figs. That has 3 sig figs. All right, so you can go through these as many times as you want. I broke it up so you can see each step. Not a bad idea to try the problem on your own and lay a piece of paper over this. You know, see how you can do it on your own. There's some of this on homework too, and again, we're going to have at the next Zoom session, the so to speak in-class session. Going to give you an opportunity to work on some more problems like this, and I will work through them with you. All right, take care. That's the last slide.